Go.
Here's the VSEPR theory. It stands for valence shell electron pair repulsion, and that just means that electrons repel each other because of like charges. The bonded pairs repel less than lone pairs. Multiple bonds do not affect how strongly they repel. Single, double, and triple bonds repel the same amount. And it determines the shape name due to how far the electrons repel each other.
Alright, this is the trigonal planar. There are 3 bonded pairs on it, and there are no lone pairs. Each angle is 120 degrees in between, and it's called the trigonal planar because there are 3 atoms all on the same plane. And then it's not polar because the negative and positive centers meet in the middle and they cancel out.
Here we have the bent trigonal planar. It has 2 bonded pairs and 1 lone pair. The bond angles are less than 120 now because the lone pair repels stronger than the bonded pairs, so now they're farther. And the polarity centers of positive and negative do not cancel out anymore, so now the positive meets down here and the negative meets up here, and now it's polar.
This is the tetrahedral. It has 4 bonded pairs and no lone pairs. Each angle in between the bonded pairs are 109.5 degrees. It's called the tetrahedral because there are 4 bonded pairs, they're on different planes. Because if they're on the same plane, then it wouldn't be as far. They wouldn't be able to repel as far as possible. And the polarity, it's not polar because the positive and negative centers for each one meet in the middle, and it cancels out too.
Alright, so we have the pyramidal tetrahedral. It has 3 bonded pairs and 1 lone pair. And this lone pair pushes the 3 bonded pairs farther than before. So now these are less than 109.5 degrees away from each other. And it's like this because the lone pair is able to repel farther and stronger than bonded pairs. And now the tetrahedral is polar because the positive centers now meet below while the negative center meets in the middle.
Alright, the name of this one is the tetrahedral bent. There are 2 bonded pairs and 2 lone pairs. The angles are less than 109.5 degrees because on this one there are 2 lone pairs and it repels them even more, making the bonded pairs closer. And then it's called that because it has the bent shape due to the 2 lone pairs. And then the polarity, the same thing, the plus and the minus centers, they don't cancel out because of the 2 lone pairs, and that makes it have polarity.
Here we have the trigonal bipyramidal. It has 5 bonded pairs and 0 lone pairs. The degrees are 120 between this plane and 90 between these bonded pairs. Why it is called the trigonal bipyramidal? It has all the bonded pairs create 2 trigonal pyramids, and then here. And then it's nonpolar because the positive centers all meet in the middle, and so do the negative centers.
Here we have the trigonal seesaw. It has 4 bonded pairs and 1 lone pair. The angles are unknown because we don't know how far the lone pair pushes the bonded pairs away. But it's called the seesaw because one lone pair pushes them away. So when you set it down, it kind of makes a seesaw shape. And then for the polarity, the positive and negative centers don't cancel out. So the positive from these is down here and the negative is up here, and that makes it polar.
Here we have the trigonal bipyramidal T-shaped. It has 3 bonded pairs and 2 lone pairs. The bonded pairs create a 90-degree angle between each other, and it's called this because the 2 lone pairs repel the 3 bonded pairs in order to create a T-shape. And in this, the positive centers don't cancel out with the negative centers at the top and the positive centers down below, making it polar.
Here we have the trigonal bipyramidal linear. There are 2 bonded pairs and 3 lone pairs. The angle here is 180 degrees, and it's called the linear because the 3 lone pairs repel them to make it 180 degrees, and that makes it linear. And then the polarity, the positive and negative centers cancel out in the middle, and that makes it nonpolar.
Here we have an octahedral molecule. It has 6 bonded pairs, 0 lone pairs. All the bonded pairs create a 90-degree angle within each other. And why it's called an octahedral is because even though there's only 6 bonded pairs, it creates 8 shapes with each other, 4 on each plane. And then this is nonpolar because the positive centers cancel out with the negative centers in the middle.
Here we have the octahedral square pyramid. There are 5 bonded pairs and 1 lone pair. On this plane, the angles are all 90 degrees, but from here to here, they're slightly less than 90 because the lone pair repels them further. And it's called the square pyramid because the 4 bonded pairs and the one up here form a square pyramid. And then for the polarity, the positive and negative centers don't cancel out, so that makes it polar.
Here we have an octahedral square planar. It has 4 bonded pairs and 2 lone pairs. The bonded pairs have 90 degrees between them all, and it's called this because the 2 lone pairs make the bonded pairs all share a square plane, and the positive centers meet in the middle, and so the negative centers cancel each other out, making this nonpolar.